I'm Debbie Holton. I'm the Vice President of Events and Industry Strategy for SME, and we're really pleased to welcome you here this afternoon. We've been just so privileged to work with the team at the Advanced Manufacturing Partnership of Southern California. Just a wonderful group of people, very vested in the future health and development and prosperity of the aerospace and defense manufacturing sector in Southern California. So I hope that you've enjoyed all the different programs that they've really helped us to facilitate here at this event this week. We had some great supplier panels we just finished up. We've got some others on workforce training and skills and opportunities for funding for that. And then really just the cherry on top of the sundae right now, which is our lunch about the technology and skills that are going to be needed for the space industry, especially here in Southern California, a very important part of the manufacturing landscape. So a little shout out to our folks too at Tooling U-SME and Patricia Carlson, who also helped to pull this panel together. So it's my pleasure to introduce Lieutenant Colonel Robert Atkins with the U.S. Air Force and the LA Air Force Base, and you're just really going to enjoy his presentation this afternoon. Please help me welcome Lieutenant Colonel Atkins.
All right, well, this will be the easiest presentation because there was no preparation whatsoever. I live space, I live the manufacturing of it, but also on the outside of my day job, I do a lot in the education of trying to get this space and the mindset of space and the changes in the technology down to the younger high school to industry professionals. So, as she said, I'm Lieutenant Colonel Robert Atkins. I've been in the Air Force for 19 years. I got in Space Command. I chose Space Command. I still remember being in college and they're like, oh, you're going in the Air Force, you're going to be a pilot? It's like, no, I don't like to fly. I don't like the way it feels. I don't like air sickness. You know, I'm going in to space. But what's odd is if you look at it, space or the Air Force, the pilot arena or the aircraft arena drives probably 90% of everything at the Air Force, right? When I went to Squadron Officer School, that's where you go when you're a captain. You team up with about 14 people each class, but there's probably about 600 of you in the whole entire thing. You have to give a job brief. Your job brief talks about what you do for the Air Force. Everybody who spoke either said, I'm a pilot or a navigator, or they all said how they support the pilot or navigator. And then it's kind of odd because I get up there and I live in this little vacuum of space. I guess no pun, but I live in this vacuum of space where my job is to get satellites on orbit and bring that capability to the warfighter downrange. And so I don't have to interface with them a lot, and I don't do things that really support the pilot in a day-to-day fashion. They need my signals, they need my imagery, they need communication, but it's kind of there. So when space is working, you don't know it's working, right? You came in today, you probably fired up Waze or you fired up your navigation system, and it told you how to get here. It was using GPS. I don't know if you noticed this, but when you pulled into the parking lot of the convention center, did it pop up and it say, I lost GPS? Well, that's because GPS, it's actually a very low-level signal, not a lot of power coming out of it. When you lose it, it's not good if you're actually trying to, regain and try to figure out where you are. But it is such a standard now, it almost seems always there. It almost seems like you take it for granted, right? If you have DirecTV or Dish Network, you go home and you watch a football game and you don't even think that there's a satellite 24,000 miles away pumping that signal into your house. If you have Sirius in your car and you listen to music, you don't even think about it until you go under an overpass and then you lose your signal because you're stuck at a light and you can't connect to the satellite again. So WESTEC, it's really neat to come here and speak to the industry and speak to the manufacturing side of it. And so when I got approached, I was thinking about who would I like to invite. Well, Tyvek came to mind. So Tyvek is in Irvine. They develop small satellites, and they also specialize in the carrier systems to put these small satellites on rockets, so on launch vehicles. And then I brought Stratolaunch because the first time I heard of Stratolaunch, the first time I started reading into it, I thought it was just a paper concept. I thought it was absolutely, we're going to advertise out there and we're going to be trying to find venture capitalist funding, and then we'll finally get our feet under us, and then we'll finally, take off with this concept. Well, I got a phone call from Roland from Tyvek, who actually coordinated for me to go to Mojave Air and Spaceport and see Stratolaunch. So when they first bring you in, they take you to a conference room. They do their whole, show telling you about what the concept is, why are they developing it, what are they doing. and then they take you into the hangar. The moment you walk into the hangar, you're actually looking at the world's largest aircraft. So it's 380 feet wingspan. It's a football field, plus the end zones, plus you have 15 feet hanging off the sides. I don't want to take away too much of George's story, but it's not a paper plane. It's not you just in blueprint state. And the reason is because in the space industry right now, we have what we term benevolent billionaires or impact investors who are kind of tired that on this whole planet, every single country is the space domain is ran by the governments. So in the United States, we have NASA, Air Force, and NRO. They're doing almost all the acquisitions, almost all the procurements, and almost all the launches. Well, it seems like when government gets involved, cost goes up and things get delayed and behind schedule. In the commercial mindset, it's fast. It's, you know, we got to move quick. We got to keep these things going. We got to drive down costs, and we got to enter the market. And so that's what these unique companies are doing now. The benevolent billionaires I speak of are these people who made money in the IT industry. And I don't know if it was something growing up in the childhood part of it and thinking how cool space was and watching us land on the moon, or if it's just now that they've got enough money that they're almost investing in an impactful way to make a difference, right? And that's what they're doing. So Paul Allen, the co-founder of Microsoft, started Stratolaunch. He came and he went to Burt Rutan at Scaled Composites in Mojave, and he said, hey, I want to design something that can carry a large launch vehicle. And that's what they came up with, and we'll hear more about it. Also, Rocket Lab's a pretty neat story, too. So Pete Beck is a native New Zealander. He got an aerospace engineering degree. He started working in the aerospace engineering field, and he really thought he was going to make a difference. So it's kind of like a lot of people in the audience right now. Right now, you're at universities, or you're just entering the job market, and you really want to make an impact, right? I mean, it really feels special to be a part of a team and watch something mature. So that's what Pete Beck wanted. So his wife had a reason to come to the United States, so they caught an airplane. They came over here. While she was conducting business, he made some phone calls to NASA because he wanted to really talk to them and really kind of maybe almost, you know, wow them with what he's doing. So after his meeting with NASA, he realized that he was just a small cog inside of a massive machine. And this massive machine is the aerospace engineering industry. We produce, we produce launch vehicles, we produce satellites, we produce ground systems that talk to these systems. On the way home, he was actually depressed. He was actually at a point where he was like, you know, I'm not as impactful as I thought I was. But what he did when he got back to New Zealand is, I think he might have been employed somewhere. He quit his job, and he started Rocket Lab. And the funny thing about Rocket Lab is their first photos you see, there's these rockets on the walls. And they're only about 5 feet. I mean, that's what we do. That's what I do with kids at the local high schools. We take these rockets and we use Estes-powered motors, and we actually put them, you know, launch them 200 yards or whatever, or feet in the, you know, in the air. Well, Pete Beck did that, but he took these baby steps. He received funding not only from NASA, but from some other investors, and he created the Electron rocket. The Electron rocket just did its first test flight, and for all intents, it was actually a successful launch. So I'll let Shane talk about that one some more too. But what my point is when you come with that creativity, and you come with the current activities that are going on right now with information technology, with data twins, the digital twins, with ideas of cloud computing, you can do some phenomenal stuff. However, the more senior people that are at the companies, they need to realize that not only do they need to learn what's going on or what's changing in the industry, but they also need to remind the younger people about things that have happened in the past. So I have a whole entire chapter, even a lesson plan that I dedicated to mission assurance. So what mission assurance is, it says, I understand you want to go fast. I understand you want to do novel things. But let me remind you about the importance of documentation, the importance of diagram, the importance of part traceability. I can tell you story after story of satellites and launch vehicles that have failed due to something so unbelievably minor. So we went to Mars. We were going to put up an orbiter. Due to a miscommunication between one of the primes and JPL, one company used the metric system in their data and calculations. The other one used the imperial system. Well, guess what happened? A lot of these satellites, they have to operate autonomously because it's like an 11-minute each way when you're trying to communicate something that's at Mars. So in the I guess you could say, an anomaly, or in the accident investigation board, they found out that due to the miscommunications, it kept trying to do these readjustments, and it ended up just plowing into Mars. We had the Genesis spacecraft. Okay, this is going to be awesome. We're going to take this spacecraft. We're going to go behind a comet. We're going to pick up some of the particles that are coming off of it, and we're going to bring it back safely to Earth. We're going to deploy a canister. A parachute's going to come out, and it's going to land in Utah, or we're going to catch it by an airplane. I don't know what their plan was because it didn't happen. It plowed into Utah at over 900 miles an hour. Well, the reason it did, the schematic was drawn wrong, and they wired it wrong. The parachutes didn't deploy. Launch vehicles. We had a defective brazing on a launch vehicle. Due to vague instructions or vague drawings, they thought it was okay and that it looked like it was acceptable, and they passed it. It blew up shortly after liftoff. We had another one where in the tech specs, it said tape the cabling up to the connector within an inch. What does that mean? What is within an inch? Is that an inch? Is that 3/4 of an inch? Is that a 1/4 of an inch? What does within mean? They realized when they taped it too much, and in space, since you're in the vacuum, it doesn't require much to separate anything. So whenever they did their separation command to fire the second part of the inertial upper stage, it got caught. And it was just caught enough to kind of kick it off and make it a little bit off-cantered, still attached. So when they went to fire it again, it threw it out of orbit, and it was a wasted satellite. The scary part is when they went back and looked at documentation of previous launches, if they watched the tip-off signature, it was doing it also. They just got lucky. So this adherence to a process, believing in the process, is what's important. But only the youth, I believe, know how to do these things that we believe, or we've been so institutionalized that you can't do it, right? You can't land rockets, I promise you. Rockets are over 220 feet tall. They're larger than the Statue of Liberty. Some of our rockets are approaching Big Ben. So if you've ever been to England and you've seen Big Ben and you think Big Ben's massive, the NASA SLS launch vehicle is going to be bigger than Big Ben. Well, how are you going to land that, right? It doesn't have wings, doesn't have lift capability. You can't do that. Well, SpaceX, some 24-year-old kid probably drew up the idea of these carbon fiber legs that are going to come out. And then he said, you know what, I'm going to put wings on this vehicle. Well, never mind, scratch that. I'm traveling at over 5,000 miles an hour. I'm falling back to Earth. If I put wings on here and I start trying to control my wings, it's just going to rip them off. So what they do, they came up with grid fins. Grid fins are almost like a cheese grater, and as it turns, it adjusts the upper part of the booster. Also, as it's returning, since it's going 5,000 miles an hour, and it was just 75 to 100 miles into the air, and the atmospheric pressure was so low, it's okay to fall that fast. But once you start getting closer, and as the atmospheric pressure starts to increase, and you start to get drag and heat and buildup, they actually have to fire the engines again, or else it'll rip the body apart. And then it continues to travel in at greater than the speed of the sound until it's only about a mile off the pad, and then it fires its engine one more time. The legs come out so softly and so fluid-like, it's just beautiful to watch, and then it lands. And now I think they've landed over 14 of their first stages. And so what is once magic or once unimaginable, all of a sudden it starts to become the norm. And that's what they're doing. These companies are coming in and saying, you know what, we can use composite manufacturing. We can use additive manufacturing. So at the National Space Symposium, I was with Shane and Brad, and they have Rocket Lab. Rocket Lab prides themselves that their engines, their Rutherford engines, are almost completely additive manufactured or 3D printed. The body itself, the fuel tanks, is almost all completely composite material. And so it's all done in-house, right? If you're using additive manufacturing, you set up your systems, you have good engineers and you have good programmers, and you program and you print it. So they spoke with the general. The general was really excited. I knew the general. So I saw him at the airport. So we're flying back. I run into him at the airport, and we start talking. And he's like, Rob, can you believe they're printing with plastic? They're making plastic engines? He's like, how do these things not melt? All right. So that is the mindset which has been in the industry and the institution for so long that they're not keeping up with the change of the industry, right? They hear 3D printing and they think about it at their local library, or even the people who go out and buy the robos and they print some cool plastic thing. I'm just like, sir, okay, sir. I need to take you to these factories. I need to bring you in there so you can see them. These space companies are printing with Inconel. They're printing with titanium. They're printing with aluminum. They're printing with copper. And they really are. And that's the way forward. What is additive manufacturing? It means you add material to what you're creating. What is subtractive manufacturing? It means you subtract. There's certain things you can do when you're adding, building it from the inside out, outside in, that you can't do when you're subtracting. So that's what's going on. One final thing I wanted to touch on. It's mainly for the young students who are in college. So I just met Chris back there, and he's going to USC. He's already doing things on his own. He's already starting his own company. That's the mindset and the hunger that has to take place. And it's so cool to see. Because when you do things like that, you not only learn about what the industry is doing, you learn about a different way of doing it. So that reminds me of Isaac Newton, right? Isaac Newton invented calculus. He invented calculus faster than most of us learn it. He also was in the early 1700s, and he came up with his laws of motion, right? An object at rest stays at rest unless acted upon by an external force. Now here's the other one, and this is the one that we need to think about. An object in motion travels in a linear path unless acted upon by an external force. So what does that mean? If your company is at rest and it's not doing anything innovative or moving fast, you're going to get ran over. But I don't want you to get your company moving so fast in one direction that when it comes time to change, when it comes time to implement something new, you're so set on this direction that you're blazing that you're not going to add force to it and you're not going to adjust to what's going on to the industry. So what does that mean for the college kids and the people entering the market? It means you need to bring that type of hunger that you have now and you need to apply it. So in a little bit we're going to do a panel and we're going to have questions and answers, but I think the first thing the question that will probably come up is, I have a degree, I want a job, but I don't have experience. Or, I don't have the experience and I can't get a job. So how am I going to either get the experience to get the job or get the job to get the experience? Well, I think it's tenacity. I think it's the laws of inertia. I don't know how you're going to apply to these companies, but you need to spread it wide, and then you need to revisit every single time. You need to call them up. Okay, I just sent my resume to you. You know, what's it look like? Oh, yeah, well, we'll call you up in a couple of weeks. No, don't take that. Call them back up again the next day. Say, hey, you know, I would like to come in on a tour. So if you're doing a tour of your facility, I don't even care if it's for another company, I would like to come in. They want to see that. They want to see that hunger. I applied for 11 jobs this last month. It's not employment jobs, it's education jobs. So what I'm trying to do is I have Space Innovation Academy. I'm taking all these lessons that we have learned from mission assurance, from launch vehicles, to the current state of the industry, and I'm opening it up in a seminar fashion at the local high schools, and I'm having military officers volunteer, and they're teaching. And so we're actually changing these young minds of these kids. We're bringing things in that I never had. I never knew anything about gravity and the force. I never knew anything about spacecrafts and how they worked when I was in high school. So we're bringing that to them. The funny thing is I'm just like you. I call up this high school, hey, I would like to, bring an officer. They're going to have the full background check. They have a secret clearance at minimum. They have top secret clearances. They have all their shots. They have proof of tuberculosis. They have all that stuff because I already know what they're going to ask me. And then I say, I would like to have them come and talk to your kids. You can do it as small as, 2 hours, or we can do it as long as 44 hours set over 2 semesters. Very few of those schools immediately grab a hold of it. Most of them are apprehensive, and it seems weird. Either they have that law, right, an object at rest stays at rest. Well, they've probably been at rest for a long time. They probably don't want to act. They probably don't want to move. But I have never been to a school when I sit down with the principal, with the local superintendent, and with their science teacher who have just blown their mind. I have never been to a school where I did not just completely blow their mind, to where they're like, oh my God, we got to have this and we got to start, next week. Well, it's Newton's law. Most of the school systems, they fall into this practice of just the same routine every year. Don't bring anything new. Don't come in with these new concepts. I had one when I first sat down. It was the superintendent, the principal, and the aerospace engineer teacher. And they said, oh, we already have a space curriculum. I'm like, oh, you do? They're like, yeah, he teaches it. I pulled out my materials. I showed him everything we're going to talk about. He absolutely said, we have nothing like this. We need this. And that's what you got to do. And so the same thing when you're going out to apply for a job. Do not drop off a resume and walk off. You now have the internet. You know who the CEO is. You know who the COO is. You know who's doing the hiring and firing. And the funny thing is if you do enough work on the internet, you can find their email address. It might not be on the website, but it might be at a local WESTEC convention where they spoke and the email address is in some panel, data. You can find their email address. Drop them a line. I love your company. I love what you're doing. I want to be a part of it. But please start out small. Don't think you're going to hit there and all of a sudden make an impact, right? You don't want to get in there and start trying to, come up with these ideas and it doesn't seem to take, hold, and then you just quit because you don't feel like you're making an impact. It comes a time. If you go get a job and you think that you have learned so much at your local university, or if you learned so much that you're going to apply, that you're going to revolutionize that industry within a year of being there, what does that say about your knowledge that you're going to take on for the next 5 years? You're literally saying you're coming equipped that you can all of a sudden shape the whole dynamics of this company? No. But can you imagine your knowledge from the university is applied with 5 years of skills work and 5 years on the job? That's when you can really start steering the ship because you see the potholes so clearly now. I'm going to show a video real quick just to show you what TIVAC's doing. They were a requested panelist, but just due to scheduling of a launch, which is how it works. So if any of you enter the launch industry, here's what you do. When you're going to get married, you put the wedding day on the launch, okay? I promise you, you will not miss the launch. That's how it works. So let's do the TIVAC video real quick, and then I'll have George speak. So thank you, everyone.
My name is George Bugg. I'm the program manager for aircraft development at Stratolaunch Systems. My background, I'm an aerospace engineer by degree. I've got 30 years of experience working in the missile development, mechanical design, fabrication, and test area. In the last 5 or 6 years, I've been blessed to be part of the Stratolaunch program. I want to tell you just a little bit about the Stratolaunch company and the concept. We'll show a video and then just open things up for questions a little bit later. Thank you, Colonel, for this opportunity to be here. So what is Stratolaunch? Stratolaunch Systems Corporation. We were indeed founded by Paul Allen. Paul, as was mentioned earlier, is the co-founder of Microsoft. He and Bill Gates got together, made a little project in the garage, and it kind of took off from there. Paul has always been just intrigued with space. He's always dreamed about going to space. He's always dreamed about putting rockets into space. So a few years ago, he and Burt Rattan at Scale Composites got together. They collaborated on a program that ended up winning them the Antares X Prize, where they built an airplane to carry a small spaceship They launched the spaceship. It went into suborbital space 2 times in a couple of months. They won the prize. And then Stratolaunch took off from there. So it turns out it's a difficult thing to build an airplane to launch a rocket. It was a difficult thing to build a small airplane to launch a small rocket. And so now we've scaled up from there, and we'll talk about that in a little bit. We were formed in 2011, and we're all 100% U.S. owned and Paul Allen funded. Paul Allen writes the checks. Paul Allen asks the questions. You might have noticed that the Stratolaunch is kind of a different concept, different PR structure than some of the other benevolent billionaires, as the Colonel mentioned. Paul's not out here for the PR. He's not out here for the publicity. We're developing an airplane and a rocket system to deliver satellites to space. When we get there, you'll hear about it in the news. Paul doesn't like to have a lot of show and tell ahead of time. We want to get that hardware done and get the rockets in the air, and you'll see about it at that point. We're located in our headquarters in Seattle because that's where Paul lives. I live in Huntsville, Alabama. Some people refer to as the Space City, Space Capital. We have satellite offices in D.C., and then, of course, we're building the airplane and doing the rocket integration in Mojave, California, just up the road. And our purpose here is to provide convenient, reliable, and routine access to space. We want to bring the airport-style operations to space, break the paradigm that space is hard. We want to have an airplane that flies, drops a rocket, launches it into space, comes back, and is ready to load up another payload within a week or so. We want to get into that routine operation where it's not difficult to get your satellites loaded onto a rocket and into space. We have a couple of key partners helping us get there. Scaled Composites is in Mojave. Scaled has been our contractor working with us for the full duration of the program from the beginning when Burt Rutan owned the company. Burt's still on our board of directors. But Scaled is doing the design and the analysis and the fabrication of the airplane on site at the Mojave Air and Spaceport. So we've got a slide here in just a minute to show you our facilities there. Originally in the program, Stratolaunch was doing the whole system. We're building an airplane, we're building a rocket, we were going to do all the integration and test, and we're going to fly all that and put 13,000 pounds into orbit. Somewhere along the line, we realized that's kind of a challenge. So we pulled back a little bit. We focused on just the aircraft. Once we get the aircraft to the point where the confidence is there, that we're sure we're going to be able to get this thing flying, then we would begin the process of developing rockets and the launch vehicles as well. So apparently I've convinced them that we're close on an airplane because we're now working with Orbital ATK and some other partners to develop those first launch vehicles. We have a long-term agreement with Orbital ATK to use their Pegasus XL launch vehicles initially. We'll carry 3 Pegasus XL rockets. The satellites that you just saw being built there in that time lapse, pretty cool. We can carry about 8 to 10 of those on a Pegasus. We can carry 3 Pegasus rockets. So you'll see a concept video here in a little bit that kind of demonstrates that we can put 3 rockets into 3 different orbits in a single sortie, a single mission of the aircraft. So we're taking known quantity with Orbital ATK. The rocket knows how to fly, it knows how to get into orbit, it knows how to drop from an airplane. All that's been proven, 30 successful flights in a row plus. So we'll develop the aircraft, reduce the risk by demonstration and time and test on the aircraft, and then we'll begin with some larger launch vehicles after that. So just how big is the Stratolaunch aircraft? You got to think big. I can describe to you that it's a big airplane. I can show you pictures of a big airplane. I can show you images from space, and it's a big airplane. But until you walk into that hangar and you look up and see the big airplane, you really can't get that image in your head. We try. Okay, Colonel Atkins told you that our wingspan is 385 feet long. So that's the back of the end zone of an American football field plus 15 feet on either side. I'm from Huntsville, Alabama, where NASA Marshall Space Flight Center is headquartered. We did the Saturn program, we did the shuttle program there. We've got a big Saturn V rocket standing up out there beside the interstate. Well, our wingspan is longer than the Saturn V is tall. My favorite, the Wright brothers could have flown their first flight 3 times and still be on our wing. It's big, people, it's big. I don't know how to describe it any other way than these pictures here. 1.3 million pound gross takeoff weight. 550,000 pounds of that is launch vehicle capacity. It's not designed for a particular launch vehicle. It's designed with, if you bring your launch vehicle to us, we'll give you a mechanical and electrical interface document, and as long as you meet those requirements, we can carry your payload. Those fuselages are right at 100 feet apart. The wing is about 30 feet off the ground, so you've got a massive volume, a massive mass capability, and if you can fit in that envelope, we can carry you up to 37,000 feet and let go of you if you want to be let go of. The airplane is large. The facility to build the airplane is large. In Mojave, California, we've got, we built 2 buildings on the Mojave Air and Spaceport. We own the buildings, we lease the land from Mojave. That back building is about, 100,000 square feet. That's our fabrication building. We built the components there in that building. The airplane is all carbon fiber with some of the 747 components. We bought 2 747s. We took the engines off of the 747s. We took the landing gear off the 747s. Some of the control systems, a lot of the actuators and things of that nature. And in that back building there, we built the carbon parts to hold on to the engines and the cabin areas. Then we built the hangar up front, another 100,000 square foot building with a huge single span opening in the front. The civil engineers love it. I'm an aerospace guy. The door's open, so that makes me happy. Our wing has about 20 feet of clearance on either side of that door. Everything is big. We have about, at any given time, we have about 200 technicians at Scale Composites working on the airplane. We have about 60 or so engineers working on the airplane at Scaled. We have another about 35 engineers in our Stratolaunch engineering staff up in Seattle working on some supporting Scaled in a lot of ways, but also working on some other in-house projects. 130 tons of carbon fiber go into this thing, well over 1 million individual parts and pieces. It's big. Did I mention it's big? Back in May, we actually got officially into our test phase. So there's still a lot of work to be done on the manufacturing of the airplane, but we're weight on wheels. We rolled it out of the hangar for the first time into the sunlight, put fuel in the tanks. Any day now, we plan to start the engines. We'll be first flight sometime next year and first mission in the 2019 time frame. So just some more pictures here, because you need to get the idea that it's a big airplane. That's when we rolled it out for the first time in May there for the fueling tests. So I think we're going to watch a little video next that kind of demonstrate the concept of operations here. I mentioned the airplane has about 1,000 nautical mile mission radius. The benefit of the flying launch pad, if you will, is that we're not bound by the fixed infrastructure at any one given place. If we've got an airport that can handle the width of our fuselages, that we can land there, we can launch from there. So we can take off, fly out 1,000 nautical miles, loiter for an hour, pull off a mission, launch 1, 2, or 3 vehicles, circle back around and land back where we started or a different location. We can pick up, we can fly into the interior of the country, we can pick up a payload and ferry it back to an airport that we want to launch from, and we can have a mission from there. So we're not fixed as the traditional infrastructure is. So that's one of the big benefits. Do we have the video? So we are looking for talent, young engineers, technicians, old engineers, old technicians. We have openings at Scaled Composites here in Mojave, California. We have openings in our Seattle engineering office as well. I'd love to talk to anybody afterwards about that. So here are kind of our website and career pages. So that's all I have for now, and we'll be glad to address questions later on and look forward to talking with you later. Thank you.
Good afternoon, ladies and gentlemen. Thank you, Debbie, and thank you, Lieutenant Colonel Atkins, for the invitation to speak today. It's a pleasure to be here and give you guys a bit of an update on what we're doing at Rocket Lab. So as I mentioned, my name's Shane Fleming. I'm Vice President of Operations for Rocket Lab. I've been working for startups for just over a decade now. My background's in mechanical engineering, and I've recently moved to Huntington Beach to spool up our production facility at our corporate headquarters there in Huntington Beach. Just give you a little bit of an introduction to Rocket Lab for those who may not have heard about us before. As Lieutenant Colonel Atkins pointed out, the company was founded by Peter Beck just over a decade ago. We were founded in 2006 in New Zealand based on Peter's dream. Came back from the US extremely disappointed, wanted to do something big, and wanted to make a big splash and start his own aerospace business. So for the first about 6 years of the company, Peter worked with NASA, with DARPA, with a lot of US organizations, developing different propellants, different engine systems, and things like that for the first 6 years. Had a small team and really delivered on those promises and had quite a good working relationship with these organizations. That really gave him the credibility as a company and as a country. In 2009, Rocket Lab became the first company in the southern hemisphere to reach space with the launch of Altea 1. It was a suborbital launch vehicle that really kind of put us on the map, and Pete kind of took that momentum and in 2011 went to Silicon Valley and started raising cash. So we're very fortunate to have very strong Tier 1 Silicon Valley backers with the likes of Coastal Ventures, Data Collective, and Bessemer Ventures. These guys have been around for a while, and they've been great to have on our board. We now have 5 locations across the globe. As I mentioned, our headquarters is here in Huntington Beach, where we're focusing on production and our customer liaising and our payload integration. We've also got test facilities, research and development, and our launch operations are all done out of New Zealand at present. I'm fortunate enough, I was the 25th employee at Rocket Lab in New Zealand, and we've just now reached 200. So it's been an extremely exponential growth curve over the last 3 years, and it's been a really exciting time for the company. We are now, I'll show you a little bit about our first launch in just a minute. So as I mentioned before, Pete really wanted to make a big splash. His big mantra is to reduce the cost of launch and increase the frequency. So in order to do that, 4 years ago we started developing the Electron launch vehicle, wanted it to be lightweight and low cost. So we started with a clean slate design with those key goals in mind. We want it to be extremely manufacturable, extremely reproducible, and easy to make and cheap to make very quickly. So it's 55 feet tall, 4 foot in diameter, fully carbon composite. We leverage the boat building industry in New Zealand. We've got some of the best boat builders in the world. A lot of our team were manufacturing the America's Cup race boats for Team Oracle and Team New Zealand, so they play for both sides. And like I said, they're some of the best in the world. So we're really proud of this rocket. It's extremely lightweight. It weighs about 1.2 tons empty, about 12 tons fully fueled, and it carries a payload of 150 kilograms to a low Earth orbit, 500 kilometer sun-synchronous orbit. We can also throw 225 kilograms to a reference orbit if required. Another thing that we're extremely proud of, Lieutenant Colonel Atkins highlighted this earlier on, is our Rutherford engine. It's fully 3D printed Inconel chamber. It's extremely lightweight. It produces about a 5,000 pound force of thrust each. We've got 9 on the first stage and 1 on the second stage. And yeah, it's really, really great to have that behind the engine or behind the launch vehicle. Another thing we're really proud of is our orbital launch range. We've designed, built, and developed it from scratch in a remote part of New Zealand on the Mahia Peninsula. It is an FAA, we do launch under an FAA launch operator's license. I had the pleasure of spending about 1.5 years down in Mahia and developing the launch site infrastructure down there, so it's a pretty exciting project for the company. And the nice thing about Mahia is it's a big peninsula in the middle of the South Pacific. It's low air traffic, low sea traffic, the weather's really good, and we can get to a wide range of azimuths and launch orbital planes. We can get anywhere from 39 degrees all the way up to sun sink. So that's really strategically nice for launch for our applications. As Lieutenant Colonel Atkins mentioned, we just recently completed our successful test flight in May of this year, something the company's really been proud of. I've got a video highlighting that mission to share with you guys if you haven't seen it before. As you can imagine, we've got a team of 200 people working around the clock really vigorously to get this thing launched. So the amount of excitement when we got off the pad, got past first stage separation, second stage separation, fairing deployment, into space was a pretty exciting moment for the company, and hopefully you guys also agree.
In all stations, this is flight on mission cord. We're starting terminal count at this time. Clock is T-minus 12 minutes. Mark T-minus 12 minutes and counting.
FSO LC on mission code. Are you confirm?
Confirm.
FTS, confirm FTS is green.
FTS is green on internal power.
PMS LC on mission code.
LC.
Confirm all separation events are armed.
Confirmed.
ROM, this is flight on mission cord. Re-verify COLA windows and confirm release of the T-minus 2-hour balloon.
RM LC on LV code. Commence fire suppression system test.
Stage 1 locks pressed. Stage 2 locks pressed.
Flight vehicle is ready.
T-minus 10 seconds. 5, 4, 3, 2, 1, liftoff. Liftoff confirmed. Vehicle is cleared to pad.
Stage 2 engine ignited.
Stage separation succeeded.
Pretty exciting moment. So as I mentioned, the company, it was a really proud moment for us to prove that our design worked. We got to space, and so we don't have any major design modifications going to flight 2, 3 through 6. So we are jumping right into full production, and that's a big part of my role is getting that spooled up. So we are actively recruiting for manufacturing engineers, assembly technicians, test technicians, and anyone who has avionics experience. So we'd love to talk to you after this conference if you are interested. Thank you.
Hi, my name's Dion Jackson. I'm with the USC Center for Economic Development, and we are here to talk about how do we put these things together to support this industry. We've got these innovative companies. They need people who can help them get things going. And then, so how do I find people with the right skills? Some of you are out there hoping you have the right skills. I'm part of a partnership. It's the Advanced Manufacturing Partnership for Southern California. And these are some of the partners that we have listed up here on the slide so that you can see we work with manufacturers, educational institutions, and government. And we're trying to bring more focus to this industry and support it here in Southern California. So as we're talking to the manufacturers, these are some of the things that we hear. They don't know where to find you, those of you who are students out there. They're trying to figure it out. We're trying to connect the dots for them. So manufacturers are saying, how do I find people? Well, sometimes, depending on, like, you're the supplier, you're making some of those parts for these innovative aircraft or spacecraft, or satellites. But when you try and figure out how to hire people, you get 100 applications and none of them are really the right thing you're looking for. Well, maybe your job description isn't the best anymore. And so CMTC, we've got some folks over here, that's the MEP Center here in Southern California. They can help you reformat that job description so that you start getting the people you're looking for. So that's just one example. Then from students, as was said by Lieutenant Colonel Atkins, how do I get that job? I don't have any experience, and they keep saying they want experience. Well, at USC and at Cal Poly San Luis Obispo, they have clubs, and I'm sure many other universities do as well, but these are two that I know of, where you can get experience by being part of the club. At USC, they have the Rocket Propulsion Lab, and last year, they got a rocket made from scratch in that year up 144,000 feet in the air. That's the highest they've ever achieved. And their goal, they've been around for 15 years, they've been doing this every single year, starting from scratch, every single year, going through the whole process. Their goal is to get it into space, to be the first student group that does that. And they have a feeling that this year they might make that. So those are the kind of people that these guys are looking for. And then at Cal Poly San Luis Obispo, they have Polysat, which is a club where they make satellites. They make the small satellites. And you go through the whole process. You learn how to put it together just like that first video that you saw. Being engaged like that, getting internships in the summer, going and talking to the manufacturers, especially if you're an engineer. If you don't have any hands-on experience, then that last one there, you're going to be designing blind holes. What's a blind hole? That means that you've just put a hole that needs to be drilled that cannot be drilled by the machines that make the pieces. So if it can't be manufactured, then your design isn't really worth anything. Having that skill, being able to walk in and say, I've designed this, and it can be manufactured, gives you a leg up. Now, those of you who are at the end of your manufacturing career, there's another opportunity for you. We are in desperate need of people with your skills who can come back and help train the next generation. Doesn't matter what machine you know how to work, there are people who don't have those skills. With the recession, all the companies, all the suppliers had to get lean. So they kept the people with the best skills. They weren't hiring young people and training them up, so now they've got this gap. How do I fill that gap? Well, that's where you come in. We need you to come back and help us teach those skills to people, give them, the wealth of your knowledge, your hands-on experience, so that they can rapidly move up and help close that skills gap that exists out there. So I also wanted to let you know what SoCal is doing. That's the acronym for the Advanced Manufacturing Partnership for Southern California. We're here to connect the dots. These are some of the workforce programs that we've developed to close some of those gaps. The one I want to point out is the Uniquely Abled Project. So it turns out that people who are on the high-functioning autism spectrum, they're very focused. They have a unique skill. They focus very well. They make some of the best machinists that you can train. One of the first graduates of the program that happened last January was hired by a manufacturer, and that manufacturer said, I have never hired a better machinist, and they're now training them up into some of the more advanced equipment. And they were trained for, just a couple of months. But that's all it took because of their ability to focus. So we are trying to close the gap. What we'd like you to do, if you are looking for some sort of answer, solution, come talk to us. We're at what booth number? 2943. It's over by the theater and the light blue Cadillac right next to us, in case you like fancy cars. So we can talk to you. We can see how we can connect the dots with you and help you with the Space Industry Explorer, or if you're one of the suppliers, you're going to work on the SLS program, or you're making small satellites, we can help you get those connections made.
This question is in reference to everybody, it seems like they're wanting to launch something into space. I've heard a lot about like space debris. Is that of concern to you guys? And what is being done about that, I guess?
So we can track the big stuff, but when it comes to tracking the smaller debris, that's what we're concerned about. So if a paint flake hits the shuttle window, it goes 2 to 3 inches in the glass. If a small fragment of metal hit the spacecraft. With that much kinetic energy behind it, it absolutely destroys the spacecraft. And so what he's asking about is the more of these satellites we put onto orbit, are we going to cause more of a debris issue? If you remember, one of the Iridium satellites collided with a Russian spent rocket body. And what happens in space is due to the vacuum and the orbital mechanics, that debris begins to spread and propagate. And now, other satellites that weren't even in the path have to worry about it because it's such a larger area. It is a problem. Some people fall back to the big sky theory, meaning that, well, you know, it's so high and it's so big that the chances of something hitting each other are not going to happen. So what we're really trying to do is we're trying to get better with space situational awareness. That means we have radars, we have on-orbit assets, and we're trying to really track things. And then if that becomes a potential for collision, we'll try to do a maneuver with the operational asset to get it out of the way. But it is a concern. It's actually a market to where some people are trying to propose solutions to it, but there's definitely not an answer yet. You can't create a net that's going to stop something traveling at 17,000 miles an hour.
My name is Ryan. A quick question for the Stratolaunch folks. I noticed in the video clips that there was cockpit windows on both fuselages. Am I misremembering that one of the fuselages is not occupied and strictly a pressurized compartment for mass balance?
Yes, that's correct. There are indeed windows on both fuselages, but our crew of 3 will reside in the right-hand fuselage. We'll have a pilot, a co-pilot, and a flight engineer over there. The other cabin is pressurized, and its main intent is to hold the electronics that will provide care and feeding for the launch vehicle. The simple answer to why are there windows is because it's easier to build 2 of the same thing. We built a cabin, we pressure tested it. Actually, those windows are straight out of a 747 with the window frames included. We pressure tested that. We got comfortable with the design, and rather than build something that was even a little bit different and have to go through the test program again, we built 2 identical cabins. Some folks ask, are you going to ever going to put people on the other side? It's not man-rated. You could potentially get it man-rated, but you'll notice if you look closely that the egress door is on the left side of the cabin. If you were to emergency egress that side, there's an engine very, very close by. So it's probably not a good plan. So right now the plan is to keep all the people in the right-hand cabin and electronics in the left-hand.
My name is Helen. I'm actually a manufacturing engineer for Orbital ATK out here in the Valley. My question is, I currently work in defense systems, but I know that my end goal is actually in space technologies. What would be your best piece of advice, or what would you recommend if you're trying to move that kind of sector?
You know, it's great that you have experience with Orbital. I think that really gets your foot in the door, so you're in the aerospace sector. You're a manufacturing engineer, and I think the good thing is, you know, everyone up here, well, we're all building stuff. So there's a lot of companies that are commercializing, they're manufacturing, and they're growing. I have a little bit of bias towards startups. I like startups because it gives you a little bit of more diversity, and you can, you know, if you start early on, you can grow with the company, and you can open doors and options into other fields if you like, or management, or you can stay technical. So I like startups because it gives you a lot of options.
I would say, first of all, you're with an outstanding company. Orbital is fantastic. The experience that you're getting on the DoD side is perfectly applicable to the space side. So I'm not sure how the management structure within Orbital works, but at Stratolaunch, we're part of the Paul Allen umbrella of companies, so it'd be very simple for anyone within our company to bounce to another area within one of the PGA umbrella companies. So I would assume that it's similar at Orbital ATK. If you show an interest and apply for a job opening, that you would very likely get that nod first. But the experience that you're getting is absolutely applicable if you are interested and need to step out of that company and go to another one.
Hi, I'm a junior in mechanical engineering at USC. It seems that there's a lot of opportunity with starting or joining startup companies in the aerospace industry. Coming right out of school, it's sometimes difficult to know what parts of the industry need to be filled with new technology or new business. I was wondering, what are some of the tips you have for students who want to be innovators or join other innovators in the industry?
Yeah, so there's a lot of exciting new technologies going on out there that are really helping manufacturing. Additive manufacturing is one of them that we discussed. There's a lot of composite manufacturing that's really getting big. They are new techniques. They are still being developed and being perfected. So any jobs or any skills that can help support that, I think, is really important. And also just building out a manufacturing base with startup companies. You know, you have a design or a design team that actually designs the vehicle, but actually you need more manpower hands-on the manufacturing line to really streamline the process, get the procedures, the standard operating procedures, the manufacturing instructions, the parts, the logistics, all that streamlined. And I think there's really big opportunities for manufacturing engineers to step up and help out to develop that process.
Another thing is the end state of our mission. It might seem overwhelming, or it might seem a little bit odd since we're dealing with orbital mechanics, we're dealing with space assets and such. But if you go to their factories, it almost looks like any factory out there right now that's bringing on or embracing cutting edge. We do pressure vessels. What is that? It's a fuel tank. Okay, so now what industries use fuel tanks? There's a lot of them. We do avionics. We do harnesses. We do wiring. We do you know, engines and things like that. And so when we're up here talking, just apply that to anything that might interest you. So if it's not space, just remember that all these companies out there that are doing manufacturing are actually trying to bring on these new technologies into their plant. So it's not the olden days, you know, with like tar-soaked railroad ties holding some equipment on it and dark lighting and, you know, you're worried about loud noises and stuff. Manufacturing is getting into the phase of computer-aided design, the digital twins that I spoke of, artificial intelligence. There's all sorts of stuff that's going on in the factories. And so when you go in there, you're going to see how sterile it is and how efficient and streamlined it is. And so that's what's amazing to me in our industry and even in other industries that are evolving. Also, the skills they're looking for are not just, you know, a ton of straight out of college engineers. They're wanting to bring in people who have vocational or trade skills. When I was at Stratolaunch, I actually went inside the cockpit, and this guy is in there doing all the wiring and stuff. So he is in the pilot cockpit. He's wiring everything up, and he was enlisted in the Air Force. He worked on the aircraft of the Air Force, and then he separated, and he got a job with Stratolaunch. But it's a trade skill. It's something that, you know, you'll do some type of on-the-job training, you'll build up their skill set, and then they can take that almost anywhere.
Don't be too focused on experience within the space industry as a hard requirement. Number one, most of our technicians that are building our airplane, they're craftsmen, they're cabinet builders, they're artists, they're sculptors, they're people who can see and work with their hands, see the big vision that the engineer presents to them and work with their hands. Quite a few of the engineers come out of non-space areas, to be honest with you. So when you're in school and you're looking for some way to get experience, don't be too disappointed if you can't find something that is building a rocket. That rocket program you're describing here at Southern Cal, that's exciting. I graduated a long time ago from Auburn University in Auburn, Alabama. We had the Formula SAE challenge, so mechanical engineers building race cars, the Formula Baja building a little desert racer car, had a solar-powered car project, a lot of automotive stuff going on in Alabama at the time. All of those skills are directly applicable. If you can work with your hands, if you can see the picture, you can understand how to come up with a plan, execute the plan, and document the plan, we can use you. I learned a lot of very valuable things in my undergraduate studies. I think the most valuable thing I learned was actually as a co-op engineer when my mentor engineer put me out in the shop, in the tool room, for 6 months working with the machinist and had to build those parts that I was drawing up. And I had to listen to the machinist cussing out the engineers all day long because nobody knew how to draw a part that he could build. Now, you guys are messing us all up here with your additive machining. You can build those parts that I was drawing originally. So, but getting that hands-on experience in any technical field will be tremendously valuable to you.
There is an accelerator here in Los Angeles that is helping startups. So if you were to see if you could get an internship with them, it's called, Libby, remind me?
Lightspeed. Yeah, Lightspeed.
No, well, there's several of them. You're hearing a couple of them. I'm thinking of Starburst Accelerator because you will then watch people who are pitching their idea and seeing what their technical solution is to a particular problem, and you'll start to get a sense of what are people trying to solve, and then by interacting with people, find out, even an internship at a company to see, well, what are the things that don't have solutions, that maybe I could fill that gap if that's where your aptitude is.
The incubator she spoke of, the Starburst, is focused on aerospace. The other one that was mentioned over here, the LA Clean Tech Incubator, focuses on clean tech industry, but beyond that as well. But there are several incubators and accelerators. We have time for one more question I saw right here.
Good afternoon. My name is Diana, and I'm currently a first-year graduate student at USC studying engineering management, and I also did my undergrad in biomedical engineering at USC. So for those in industry, I'd like to know what has been your highest and lowest point in your company.
High points are hard for me because I've been just really lucky to have outstanding jobs along my career. Obviously the current job is always the best job, right? Because I get to go out and touch and look at and help build and help design the world's largest airplane. That doesn't happen every day. I've had some really good experiences with working military programs and law enforcement community programs and other things. Low points, I'm sure there are some. The low points in my career are always, I think, associated with jobs that involve sitting behind a computer all day and not being able to interface with people and work with my hands. So, but you have to put up with some lower points to bridge the gap to the next great opportunity.
So I would say the high point for me most recently was just after our first launch. I don't think you can beat that. After 4 years of working towards a common goal with a really motivated team to launch our first rocket, so that was extremely incredible. I would say the lowest point was probably the day after, because you can't get any higher than that, and then you're trying to figure out what you're going to do next. So what comes up must come down. So yeah, I would say it was just after the high point.
There's no such thing as a bad job in the Air Force. For the most part, it's probably true. But what happens if you get a job that you don't like, or you want to call it a bad or a low point, I think it's about attitude. I think the saying, grow where you're planted, right? I mean, it might not be the greatest soil and the greatest amount of water, but if you're in rocks and stuff, I mean, just make it happen, you know, keep that positive attitude. I remember being a junior officer, and this guy came and spoke kind of about leadership, but one thing is he, on the easel, he drew out your career, you know, your job. And then he drew out on the sides, and he called them the fields of crap. And so it's the things that try to interfere with your attitude and with your focus of your job. And sometimes you'll work around people. It's going to happen, and they're the cynical ones, right? They're the ones who always seem negative, and they're always talking about, you know, some boss, you know, is asking you to do this. And yeah, it's a fair request. It's a fair request. Let's get it done. But for some reason, they always want to make the negative out of it. Just ignore that stuff. You know, don't surround yourself with that mentality. Just stay focused. Stay. You know what? I'm gonna change this. Yeah, it's not fun. It's not enjoyable, but I'm gonna make it work.
I actually work for the American Aerospace Technical Academy. We teach non-destructive testing to veterans and underserved communities. And I'd like for you to just touch on what other technical training or skill should engineers focus on aside from the direct space. Does that make sense? So what other technical training should engineers and even people who are interested in getting into space, what other technical training should they go after? So welding, non-destructive testing, all of these where there are shortages in the industries. Can you give me some advice on, or at least to the students? A lot of times they want the direct engineering experience, but it's that other technical training, hands-on machinist experience that will make you a better engineer anyway. So I hope that makes sense.
Yeah,
Thank
absolutely.
you.
Thanks, Megan. Yeah, so I can speak about what we're doing at Rocket Lab. So we are hiring manufacturing engineers at the moment, but actually the majority of our workforce that we're recruiting for is technical labor on the assembly and test lines. So the type of people that we're looking for are CNC machinists, additive manufacturing technicians who can operate the machines, you know, sieve powder, feed the machine with powder, replace the parts when they're done, cut the builds off the build plates, things like that. We're also looking for precision welders, you know, not just people who can, you know, stick weld steel, but guys who can do high precision, you know, Inconel welding, you know, very high precious alloys, things like that. We're looking for assembly technicians who can assemble rocket engines or different assembly pumps, things like that. And we're also looking for test technicians, so people who can run the vacuum chambers, the vibration tables, the thermal chambers, those types of things. We're also looking for a lot of avionics assembly technicians, people who are very familiar with printed circuit boards, who can inspect those boards, clean those boards, do soldering, through-hole soldering, surface mount soldering, those types of skills we're actively looking for and recruiting on a daily basis.
I would say too that, especially speaking to the engineering students in the room, all of the things that we're talking about here are critically important to you as the engineer to understand. I certainly can't do more than stick weld the steel plates together, but I understand what it takes to have a precision weld. I understand what it takes to be the machinist or the machine operator and to get that part done. It's very important that you not consider the engineering staff to be completely isolated from the technician staff. I associate it, sir, with I have two sons, both in the Army. One is enlisted, one is a junior officer. It happens that the older son is the enlisted man, the E5, and the younger son is the second lieutenant. The first thing that my older son told his little brother was, "You outrank me on paper and on your shoulder here, but my experience and those with the experience similar to mine are going to save you when you come to a decision that needs to be made." So keep that in mind. If you're the engineer, the commissioned officer, if you will, that machinist that doesn't have anything more than a high school degree, other than 30 years of experience getting the parts made, he's seen more designs that worked. He's seen more designs that haven't worked than you have. He's seen parts that can be made and parts that can't be made. And if you can relate to that person and understand where that person's coming from in the manufacturing world, you'll be a much better engineer and designer down the road.
So we don't go to college, and nobody goes to college to learn facts and formulas. You can do that right now with the internet. So if that was the case, the internet would have made it obsolete to go to college. Right now, my kids think I'm the smartest person out there. They ask me a question, I don't have a clue. Within 5 seconds, I've got the answer for them. And it's teaching me too. So why is the sky orange at sunset? Why is something about a plant? You just Google it, and you got the answer. You go to college to learn about theories, how to think differently, and how to apply your different thoughts or your different processes in a different situation or a new situation. You also go to college to effectively learn how to communicate and how to work as a team. That's what college is for. And so whenever you take that approach, you need to figure out a way that you apply it to your daily life. The washout rate of engineers at most universities can be as high as 50%. And the reason that's the case is because they think they're going to go there and they're just going to learn it, and they're not going to apply it. The most successful engineer is the one who's already in the workshop, already bending metal, already doing software programming. Then they go to college, and as they're evolving in their freshman, sophomore, junior, senior year, they're bringing it home every night and they're applying it to whatever they're building or developing and learning. That's where it happens. It happens whenever you make it a part of your lifestyle. And so the work that you take on to college and you take it with you, you also live it in the outside world too.
That concludes our panel. Thank you so much to our speakers today. I was so excited to hear the word manufacturing engineer said about 47 times. SME used to stand for the Society of Manufacturing Engineers, so that is really where our heart and our heritage is, so thank you so much for that. And we look forward to seeing you at WESTEC today at the exhibits. All that technology they're talking about is out there, composites and additive and everything you need to know. And I know our speakers will be here for a little while to take your individual questions if you like. So thanks again to our panel, and thank you for being here.